Now, sensor-based application or sensor-based variable rate application is a very different type of application technology. In this case, we're not using a map, but rather using some sort of real-time sensor to determine differences in crop health. This is a slide provided by Topcon, which shows an example of tractor-based sensors that are actually looking forward or looking out to the side of the tractor to determine the health of that plant, and then will automatically change the rate of nutrients applied in order to match that requirement of the plant itself. Currently, there are three major brands, both Topcon, Trimble, and Ag Leader, that provide active crop sensing technologies. So how do these really work? Well, if we look at at how these work, they work on the properties or principles of light-based reflectance. So there's a certain amount of light, either natural light or artificially supplied light from the sensor itself, that is applied or asserted onto the plant, and a portion of that light will be absorbed or passed through the plant, and a portion will be reflected or sent back or away from the plant. And this is how plants have their different visible color. And so essentially what we're doing is we're measuring how much light is being reflected back in certain calibrated wavelengths, and in doing so we're using that or calibrating that to a specific nutrient requirement or nitrogen requirement of that plant. So as the machine goes through the field, it is constantly, every few seconds, taking a calibration of plant health and using that plant health in order to determine what the accurate or most needed application rate is at that particular time. So what's shown here is the Topcon version of this. Topcons are, as I said, cab mounted, so they have a set of sensing eyes on each side of the tractor cab, and they are aligned out perpendicular to tractor travel and allow for a 3-meter sensing area out from the side of the vehicle. Now, Trimble has a similar type product known as the Green Seeker. Green Seeker was originally developed by a company called Entech and was recently bought and now marketed by Trimble. But they mount a similar type of reflectance-based sensor out on the boom of the applicator. And these are in line with the row and shining down right on the row of corn or wheat in many applications. Here's another look at a number of green seekers mounted to the back of a liquid sprayer. Again, could be used for liquid nitrogen application. The concept here is the same, and although each of these sensors has a little bit different fundamental operating technology, the concept is the same in that they're providing a light source down to the ground and measuring the health of that crop. So here's another few photos from Trimble showing different types of mounting technologies, whether it be for anhydrous applications, liquid sprayer applications, self-propelled sprayer applications where they're knifing in fertilizer, or pulling a liquid fertilizer applicator through the field. With all these technologies, they are based on the plant standing and the plant being available for crop. So there is a requirement that you do side dress your corn or your wheat or whatever you're applying to, and that you intentionally don't apply the entire application rate to that material during the pre-emergence fertilizer application. Ag Leader has recently partnered with an outside manufacturer to market the Optrix crop sensor, which again works in a very similar method of providing a light source and measuring the reflectance of that in order to determine the amount of material that should be applied, or amount of fertilizer that should be applied. So let's look at a few examples of the type of outcome or output that can come from these sorts of sensors. These happen to be from Ag Leader, but this is a field that was used or recorded with the Optrix sensor And you'll notice that it looks somewhat similar to what a yield map might look like, where you have areas of much potentially higher yielding crops, or areas that are indicating a much higher level of vegetative index or plant health overall, and you have areas of lower yielding crops. And the intent here is that you would tend to put more fertilizer into those areas of lower producing crops and put less fertilizer into the areas that are already doing very well. So your total application of fertilizer across that field may not change, but at the same time, you're going to get the right material in the right spot to provide the most benefit. Here's another example of that, where they did a test plot field in which there was small zones, like shown here in the variable rate section of this application map, where the Optrix sensor was used to apply fertilizer. Right above it, in this zone that's pretty much all orange, that was the control, or the non-Optrix controlled region. And you can see how they got much higher yields in these areas where the Optrix sensor was utilized. And many of these companies have been doing years of research on the profitability of these sensors, and they're starting to show some quite significant benefit to users. Ag Leader has been publishing data for the last 2 years on testing that they've done mainly in 2008 and 2009, which across several states in the Midwest have shown strong correlations for productivity output from these Optrix active crop sensing technologies. In this case, in 2009, every field, or virtually every test plot they did, resulted in some level of profitability, ranging from around $3 an acre up to sections in Iowa that reached an average of $33 an acre of overall profitability.